The reason one campus cafe stays calm while another falls apart usually comes down to the hidden structure operating behind the counter. We call this structure a system, basically a bunch of different parts tied together so they can work as one single unit. Inside this setup, we identify individual components: the barista, the espresso machine, and the cash register. These are joined by links. Information flows from register to barista, and physical items like beans move through the machine to reach the goal. This diagram represents that same idea. A boundary contains all the linked parts inside the system, separating them from the environment, which is just the chaotic campus world outside the shop's walls. Once you can see these boundaries and links, you have a way to look past the surface of any complex organization and see how it is actually put together. As systems get bigger, they start to hold smaller systems inside them. We call this process system decomposition. Some parts are simple, like a single spoon, but others are subsystems. That pastry kitchen in the back has its own internal parts and links, even though it acts as just one piece of the larger cafe. The plan for how we arrange these pieces is the system architecture. This is the set of rules and patterns that dictates how the different parts are allowed to interact. Good architecture creates a smooth path for workers to follow. That architecture might place the espresso machine in a spot that causes everyone to bump into each other, creating a bottleneck that slows down every order. Architecture isn't just a list of the equipment you own. It's the strategic design that forces those parts to work together. Computers are organized using these exact same rules. Think about the cafe register. The customer acts as a client making a request, and the cashier acts as the server who has the centralized power to fulfill it. This is client-server computing. This centralized model makes it much easier to keep data consistent and secure because everything lives in one spot where a professional can manage it. The other way to do it is peer-to-peer computing. Here, there is no central cashier. Every computer is an equal, sharing files directly with one another like students sitting at a table swapping notes. Choosing between these two is simply a matter of deciding whether your problem needs strict central control or decentralized sharing. This brings us to cloud computing. This is the decision to stop owning your own computer equipment and instead rent those functions over the internet. It's like our cafe deciding to sell their ovens and instead rent baking time from a massive kitchen facility down the road. There are different levels of rental. The top level is software as a service. You are buying a finished product that just runs on your screen, like buying a pre-made cake. The middle level is platform as a service. You are renting the specialized tools and web servers needed to build something new. You've rented the kitchen, but you still bring your own recipes. The base level is infrastructure as a service. You are renting the raw machines and the digital network. This is like renting an empty warehouse with power lines, so you can build your own custom setup from scratch. This diagram compares these rental levels to the actual layers of a computer. Notice how the software level at the top matches the programs you interact with, while the infrastructure level at the bottom handles the raw hardware and the network tying it all together. The cloud isn't a magical place. It's an architectural choice about how much of the system you want to manage yourself and how much you want to pay someone else to handle. These concepts don't just work for small shops, they apply to the biggest companies in the world. Look at this business organization chart. It's a decomposed system where a massive corporation is broken down into subsystems like marketing, IT, and finance, and the technology must mirror that structure. This chart shows how different databases for customers and products are linked together to serve those specific departments. Whether it's one barista or a global finance department, the logic is the same. A request comes in, it moves through a link, and a specific part of the system is responsible for the result. When you start seeing organizations as a series of parts and boundaries, you have a practical way to make sense of any technology you encounter.